Hello everyone, welcome to the weekly lecture videos once again. This is the second video of chapter 11. Thus far in this chapter, we have concentrated on individual assets considered separately. However, most investors actually hold a portfolio of assets. Okay, all we mean by these is that investors tend to own more than just a single share, bond, or other asset. Given that is so, portfolio return and portfolio risk are of obvious relevance. So in this video, I'm going to discuss about this portfolio expected return and variance. There are many equivalent ways of describing a portfolio. The most convenient approach is to list the percentages of the total portfolio value that are invested in each portfolio asset. Okay, and we call these percentages the portfolio weight. Okay, for example, if you have $50 in one asset and $150 in other asset, your total portfolio value is $200, right? The percentage of your portfolio in the first asset is 25% because $50 out of 200. Okay, and the percentage of the portfolio in the second asset is 75%, 150 over 200. So portfolio weights therefore are 25% and 75%. Okay, and notice that these weights they must add up to 1. Okay, now how we calculate portfolio expected returns. Okay, so let's go back to our previous example of where we had different situations and we had weights for each of the situations. So we multiplied and summed them up to get the expected return. But in this case, to calculate expected return of a portfolio, so expected return of the portfolio essentially is the weighted average expected returns of each asset. Okay, so what we do is, for example, if you have multiple assets in your portfolio, we will calculate expected return for each of the assets. We have learned how to calculate expected return for each asset in the previous video, right? Okay, so we calculate expected return for each of the each of the asset, and then we multiply the weights of each of these assets, sum them up, so we get the expected return of the portfolio. Okay. Now let's go back to our previous example of QE and EMO shares. Each has a 50% weight in the portfolio. Okay, and you remember this is what we had previously in the last video. So what we do is we calculate portfolio expected return in this way. Okay, so first of all, 50% chance that the return will be negative 20% and 50% chance that the return will be 30%. Okay, so expected return, and we multiply it by 50% because that's the weight of EMO. Okay, and we see that the expected return in recession is 25%. And similarly, we find out the expected return of boom is 20%. Okay, now this is the expected return in recession, and this is the expected return in boom. And don't forget that this expected return in recession consider the weights, okay, and corresponding return in different states, and expected return of the portfolio is 22.5%. Okay, so this is how we calculate the expected return of a portfolio. So the expected return essentially is the weighted average of individual returns. Now let's come the question of variance. You need to remember one point that when we calculate expected return of a portfolio, we have individual assets and we have individual asset weights. So a portfolio return is the weighted average of individual asset returns. Now, as far as the standard deviation is concerned, you could argue that, okay, for a portfolio, we also have a standard deviation of individual assets and we have weights. So the portfolio standard deviation should be the weighted average standard deviation of individual assets. And if we calculate in this way, the standard deviation should be 27.5%. Okay. However, that approach is completely incorrect. Okay, completely incorrect. This is because when we talk about the riskiness of a portfolio, we do not consider the riskiness of individual asset. Okay, we consider the contribution of individual assets or the overall riskiness of a portfolio. Okay, and this contribution might vary depending on how these assets are correlated. Okay, if they are positively correlated, then they will contribute to the risk in one way. If they are negatively correlated, they will contribute to the risk in a different way. Okay, and here comes the concept of diversification. So when you have multiple assets in your portfolio and these asset returns are less than perfectly positively correlated, then there will be some offsetting impact on the risk. Okay, for example, let's say the two assets are negatively correlated. So negatively correlated means if one asset return increases, another asset return will decrease. In that case, when you put these two assets in a portfolio, that will have an offsetting impact. The risk of one will be offset by another. As a result, the standard deviation of a portfolio should be less than the weighted average standard deviation if they are less than perfectly positively correlated. Perfect positive correlation means that the correlation coefficient is 1. So if one asset return increases, another will increase in the same direction by the same magnitude. That's why there won't be any diversification benefit. Okay. We will discuss about diversification more detail in the future videos. Okay, so you can see that apparently we calculated expected return of a portfolio is the weighted average return. Okay, and standard deviation of a portfolio should be the weighted average standard deviation. However, that is not the case. As I said, that due to the diversification, there will be some offsetting impact. Okay, and this is how we calculate portfolio risk. Okay, so these are the probabilities, these are the expected returns, deviations. Then we square the deviations, and deviations are multiplied by the probability, and then standard deviation is calculated. Okay, so if we use the data that we have used previously, then this is how we calculate the standard deviation. Okay, so as I previously told you that using the QE and EMO example, if we calculate the weighted average standard deviation, that should be 27.5%. Okay, however, you can see that standard deviation that we calculated is 17.5%. So it's essentially 10% lower. Okay, 10% lower. As I said, that these lower standard deviation come in because of the diversification benefit. Okay, there is an offsetting impact of risk of one is offset by another. Okay, so more detailed discussion about diversification will be coming in the next video. Thank you very much.